MDM4U 6.1 Basic Probability Concepts. Theoretical probability is the chances of an outcome based on possible outcomes. So the probability of an event A is the number of ways in which event A can occur divided by the total number of ways any event can occur. In other words, NA is the number of outcomes in which event A occurs, and NS is the total number of possible outcomes. Probabilities may be expressed as a fraction, percent, or a decimal. And the likelihood of an event is a value between 0 and 1 inclusive. 0 meaning that the event will never occur, 1 meaning that the event is certain to occur. The probability of an event A plus the probability of the complement of an event A is equal to 1. Remember that the complement of an event is the opposite. So, for example, let's say that the probability of an event is 1/4. Then the complement must be 3/4 in order to equal 1. So the probability of an event occurring or not occurring is equal to 1. And what we can do is isolate either the probability of the event occurring or the complement in order to be able to solve problems in probability. So let's look at some problems. What is the probability of flipping heads 3 times in a row? We've seen similar problems using counting techniques, but now we're going to apply this to probability. So we can count the total number of outcomes using a tree diagram where the right column demonstrates the outcomes of this experiment. In this case, there's one case where we get heads, heads, and then heads. Out of the total 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. So we're applying the definition of probability to get 1, the number of ways in which the event A can occur. There's one way in which we can get heads, heads, heads. And then there's a total of 8 different ways in which we can have any outcome. Next, what is the probability of rolling a sum of 7 with 2 dice? So, it's helpful to be able to see every single outcome, and this table is very helpful for outlining all outcomes in the sum of 2 die, where this is considered to be 1 die and this is the second die. So, this is helpful because we can count the number of ways in which our event A can occur, rolling a sum of 7. This happens 1, 2, 3, 4, 5, 6 times. Out of the total, well, if this is 6 by 6, and these are the outcomes in the white portion of this table, there's 36 total possible outcomes. So we can say 6 out of 36, which when reduced is equal to 1 out of 6, dividing the numerator and denominator by 6. So this is theoretical probability based on the possible outcomes without producing an experiment. But experimental probability is a well-defined process consisting of a number of trials in which clearly distinguishable outcomes are observed. Trials, a step in a probability experiment in which an outcome is produced or tallied, and an outcome is a possible result, a component of an event. A sample space is the set of all possible outcomes in a probability experiment. So all of these terms will be helpful when conducting experiments. But the experimental probability of an event is based on observations in an experiment. So the probability formula changes. The probability of an event A is equal to the number of successful trials out of the total trials. So notice that the word trials is being used in both the numerator and denominator because this is based on observation. And some things cannot be calculated using theoretical probability. So for example, the top NBA free throw shooter is Stephen Curry, and the probability is 0.9047, a very high shooting percentage. So This is based on the total number of shots made divided by the total number of shots taken. Each shot can be seen as a trial. Next, a teacher practices bottle flipping in a desperate attempt to gain acceptance from his students. His tallied results are recorded below. So if we look at the tally chart, again, this is a good way of keeping track of an experiment and count live, so that every fifth success or fifth failure, we will draw a line through to make it easier to count, as opposed to writing numbers. So that being said, what is the probability of success? We need to count the total number of trials. So there's 6 and 14, making a total of 20. And the number of successful trials divided by the number of total trials is 6 successful outcomes, or trials, out of the 20 trials. And that's equal to 0.3 or 30%, fraction, decimal, percent. All are equivalent statements. Good luck.